Hello everyone. In this session, we are going to continue our data structures in Apex series, and we are going to solve some interview questions for linked list. These would be Leetcode questions. So let's start. So these are the questions which we would solve in this video: Leetcode 206, Leetcode 141, and Leetcode 21. So let's start with Leetcode 206. Let me go to the Leetcode screen and let's start. So the Leetcode 206 reverse a linked list. We are given the head of a singly linked list. We have to reverse the list and then return the head of the linked list. Let's say we have a list 1, 2, 3, 4, 5. The reversed order would be 5, 4, 3, 2, 1. Okay, now let me go to my VS Code. So there are two ways to solve this question. We can either do it recursively or we can do it iteratively. Recursively means using recursion. Recursion is another concept in the data structures which we can use. Or iteratively is like without recursion, you will use for loops or any loops to solve your question. I feel iteratively is always better to better approach to solve the question instead of recursively. So let's start. So if you remember from our last video, we had developed this linked list implementation class. And if you don't know, let me go to my developer console. So this linked list implementation class contains a variable head that is a reference to the linked list class. And here we'll have different methods. We'll have add element to linked list, print, the get element, add at specific index, and delete at specific index. This is the linked list class. It has two variables. One is to store the data and one is to store the reference to store the next pointer. Now to solve this question, we need multiple pointers. So we will have one prev pointer and one current pointer. As the name suggests, prev pointer will point to the previous node and current pointer will point to the current node. So when we initialize, the previous pointer is null. This previous pointer is null and the current pointer is the starting node. The starting node is the head of the linked list. Then we are initializing a temporary node. Now this, let's say we have an input of 1, 2, 3 and 4 and our head is at 1. That is the first node. Now as I told you, the current will be initialized to the head, and we are checking while current is not equal to null. We are storing the current dot next in the temporary variable, because if we don't store it somewhere, we will lose the reference. Then in the current dot next variable, we are storing the previous node. So let's say our current is 1 right now and our previous is null, and then I'm pointing the next node of the current to the previous node, because in the end we have to rotate it, right? So we'll have to point the next node of the current pointer to the previous one. Now what we'll do is we'll make the previous node as the current pointer and the current pointer as the temporary pointer. The temporary stores the current dot next, right? So the current will move one step ahead and our previous will also move one step ahead. Now we are going to repeat this full process till current is not equals to null. So the first time this link, our new linked list would be 1 pointing to null. The second time it would be 2 pointing to 1 and 1 pointing to null. Similarly, we'll fully reverse this linked list. Now let's solve it through code. So I'll use this code. I'll go to my execute. I'm going to click execute. Let me click debug only. And let's say our linked list was 5, 1, 4, 2, 3, right? So what would be the reversal of this? 3, 2, 4, 1, 5, 3, 2, 4, 1, 5. Awesome. So if I'll show you the code as well, it is the same code which we saw in the VS Code. This is the reverse linked list. We have the previous node, we have the current node, we have the temporary. We will have a for loop which will reverse the linked list using the current and the previous pointers, and then in the end I'm using this dot head is equals to previous. I'm overriding the head value with the previous node. The previous node will be the head pointer of the new linked list, of the reverse linked list. So yeah, that was an easy question. Let us go now. And the second type of questions in the linked list that are asked are, find whether a linked list has a cycle or not. So what do you mean by cycle? So let us go to the Leetcode screen and see what do we mean by cycle. Okay, so we have this diagram as well. So it's saying that given the head of the singly linked list, determine if the linked list has a cycle in it or not. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So as this image suggests, you from 3 you will go to 2, from 2 you will go to 0, from 0 you will go to -4, and from the -4 you will go again to 2, and this is a never ending cycle. This is a cycle because you cannot go out. If you remember, while iterating through the linked list, our exit condition was while the current pointer is not equal to null. If the linked list has a cycle, the current pointer will never be null. So that is the thing we have to check if the linked list has a cycle or not. Now they also ask us, like, can you solve it in big O of 1, that is constant memory? One way to solve this is like creating a set. So if you haven't already watched my collections in Apex video, we can use a set. A set will store the reference of a class, and if we will check if what we will do in that case, we will store all the pointers we have visited. Then from -4 we will again visit 2. We will check if 2 is present in the set. If it is present, yes, there is a cycle. But they are telling us, can you solve this question in constant memory? What do you mean by constant memory? It's like without using any set, any map, can you solve it? So this is a challenging question. Now let me go to my slide. So there is an algorithm, Floyd's cycle finding algorithm. So this algorithm is like, as the name suggests, was given by Floyd. So this is a pointer algorithm that uses 2 pointers, and those 2 pointers are moving at different speeds. This means that it will be using 2 pointers, one moving twice as fast as the other one. The faster one is called the fast pointer, and the other one is called the slow pointer. So what we will do in this algorithm, so we will traverse over the linked list, and there can be 2 cases. Either the fast pointer may reach the end, that means there is no loop in the linked list, or the fast pointer will catch the slow pointer at some time. Therefore we can say that a loop exists, and that means there is a cycle in a linked list. So this will be better understood when I show you the code for it. So this is the linked list 141, and let me little bit zoom it. So this is our code. Okay. We will have 2 pointers, one slow and fast, as I said, and we will store the reference of this dot head in the slow and the fast pointer. Now we will check while fast is not equal to null and fast dot next is not equal to null, then we'll go to the next iteration, slow dot next. Now for the fast pointer, as I told you, fast is moving twice as fast as slow, so we will do fast dot next. So it will move two places ahead, like unlike slow, which will move 1 place ahead. Now our condition is there would be a time when both slow and fast will be equal, because in the end fast is moving twice as fast as slow. So if that is true, then return true. That means a cycle is present. Otherwise return false. Cycle is not present. How I can demonstrate it? Let me copy this and let me go to the execute anonymous window. Okay, so we are initializing the linked list implementation class. We are creating a linked list, and you can see I am passing false or true here. After this loop, I am passing another element, add element to linked list with value as true. So let's see like what it does. So if I go back to the add element to linked list method, now if add cycle is true, I am adding the new node which we added. In the next part of it, we are adding this dot head. So if I'll show you the diagram, so this is our head 3. Now what I'll do is once I add -4 to it, I'll point this to the 3 element. So that means we'll have a cycle. This is what I'm doing through this code. And if I'll go here and let's see, let me click on execute and let's see if it prints the correct answer or not. Debug only, and boom, hash cycle is true. That means we have a cycle. Let me comment out this thing, and now we don't have any cycle because we are not passing any parameter as true. Now let me click on execute and debug only. We have hash cycle as false. So awesome, we have solved it. So this is the algorithm which we use to find whether a linked list has a cycle or not, and this is a very useful algorithm. Now let me go back to the linked list questions. So we are going to solve another interesting question, that is merge two sorted linked list, Leetcode 21. 21 merge two sorted linked list. You are given two heads of the linked list. Merge the two linked lists into one sorted list. So I think this is pretty straightforward. So we are given the first linked list, we are given as 1, 2 and 4, and the second one is given as 1, 3 and 4. So the final linked list should be 1, 1, 2, 3, 4, 4. Because 1, 1 is like both these elements. Then it should be sorted. That means 2 is the next element, then 3, then 4 and 4. And if it's empty, like you have to return whatever values that are present. Let me go back and let's solve this. Okay, so this is the method which we have created. What we are doing, this method is being passed to linked list 1 and the linked list 2. These two are the heads of the linked list, right? And these two are sorted linked list. The values are, we are sure that these two are sorted. Now what we are doing, we are creating a dummy node by initializing some empty value to it. Then in the current pointer, we are assigning dummy. Now this while loop is interesting. We are checking while L1 is not equals to null and L2 is not equals to null. That means both these linked lists are not null. Then we are checking the data part of L1 is less than the data part of L2. If that is true, then what we are doing is we are adding L1 to the current pointers next, the next of the current pointer, and then we are moving the L1 by one step. Else the data part of L2 is less than the data part of L1. Then what we are doing, we are adding L2 to the current dot next and moving the L2 linked list by one step. So it's pretty straightforward, right? Because we have to create a sort, we have to merge two sorted linked lists. So whatever is the smallest, since here L1 is the smallest, we are adding it to a cur pointer, and here in the else part L2 is small, the data part of L2 is small, so we are adding L2 to the next pointer. Then after these two, we are moving current by one step. Now what will happen next? So one of the condition would be false. Either L1 is false or L2 is false. So now what? Now the leftover part, we are checking if L1 is equal to null, then add L1 to the next of cur, or L2 or otherwise add L2 to the next of it, because when the execution moves out of this while loop, one of the condition must be false. So we are checking if was it L1 or was it L2. In the end, we are returning the next part of the dummy node, because you know, right, like we started adding the data from the current dot next. So the current dot next would be the head of the new merged linked list. So yeah, hope you understood it. Now let's go ahead and let me copy this execution code, and let's see. Let me go to the execute anonymous window, So what we are doing here, we are creating a linked list 1 and we are adding elements to it, that is 1, 2, 3 and 4. Then we are printing this linked list. Then we are adding 1, 3, 7 and 9. Then we are printing this linked list, the second linked list. Then we are calling the linked list solutions print linked list method and method the merge to linked list and providing the head part of linked list 1 and the head part of linked list 2. So let's see if it is able to solve our problem or not. Let me click on execute. Let me click debug only, and we have the first linked list is printed 1, 2, 3 and 4. The second one 1, 3, 7 and 9. And this is the new linked list that is merged of these two. So we boom, we have successfully solved this question as well. Now let me go back to my PPT. So I'm going to give you a homework. You have to solve Leetcode 61 rotate linked list using Apex programming language in your Salesforce org. And also one more thing. So if you want my existing code which I've implemented for the solutions, then do comment and I'll create a GitHub repo and I will share the code with you guys. So thanks everyone for watching the video. And after some long time, we have continued with the data structures in Apex series, and do subscribe to my channel for more such videos in the future. Thanks everyone.